Pi-hole and VPN ad blocker. Setting up a Pi-hole and VPN on a Raspberry Pi offers an affordable and effective way to enhance network functionality and security. The Pi-hole provides cost-effective ad blocking across all devices, reducing distractions and bandwidth usage while ensuring privacy by keeping DNS queries within the local network. This eliminates reliance on external services and enhances control. Similarly, a self-hosted VPN adds a layer of security by encrypting internet traffic, protecting data from eavesdropping on public networks. Hosting your own VPN also grants complete control over server operations and data handling, eliminating dependence on third-party providers. Together, these tools create a private, secure, and efficient network solution. This project demonstrates the practical use of the Raspberry Pi's ARM-based architecture to manage DNS queries and VPN encryption efficiently, utilizing its processing power, memory, and storage for resource-intensive tasks. The setup showcases how hardware and software integrate within the network system, specifically leveraging DNS sinkholing and VPN tunneling technologies. These components work together to secure data flow and improve network efficiency, highlighting key concepts of network and system architecture. Optimizing the limited computational power of the Raspberry Pi is a central focus, with careful resource allocation ensuring smooth performance even under moderate network loads. This demonstrates effective application of resource management principles, achieving robust functionality without overburdening the hardware. Financially, the project offers substantial cost savings by replacing recurring subscription fees for commercial ad blocking and VPN services with a self-hosted, low-cost solution. This makes it an accessible and practical choice for individuals, households, or businesses seeking enhanced security and privacy on a budget. Scalability and flexibility further enhance the solution's value, allowing it to adapt to increasing network demands with minimal adjustments. Whether accommodating additional devices or expanding VPN capacity, the setup provides a sustainable and future-proof option for privacy and security, meeting both immediate needs and long-term goals. For the Pi-hole side of this project, I followed the recommended guide from Pi My Life Up. The guide provided a clear, step-by-step instructions that made the installation process straightforward. Using the Raspberry Pi, I was able to install the Pi-hole software without encountering any issues. The setup process included configuring the Pi-hole as the network's primary DNS server, which allows it to block advertisements and malicious domains across all devices. This smooth installation reinforced the reliability and user-friendliness of the Pi My Life Up guide. For the OpenVPN portion of the project, I relied on another detailed guide from Pi My Life Up. The guide walked me through the process of turning the Raspberry Pi into a secure VPN server, ensuring encrypted connections for remote network access. While most of the steps were straightforward, I did encounter some challenges towards the end of the setup, particularly during the configuration and testing phases. These issues will be addressed in detail on the troubleshooting slide that I have later in this presentation. Overall, the Pi My Life Up resources were instrumental in successfully completing both components of the project, providing comprehensive and easy-to-follow guidance for even the more complex aspects of this VPN setup. The installation of Pi-hole was a straightforward process, and the results from my setup are shown here. Once installed, Pi-hole acts as a centralized solution for blocking ads, trackers, and malicious domains across all devices connected to the network. This significantly enhances browser speed by reducing the number of unnecessary requests made to external servers, which also results in lower bandwidth usage. One of the key advantages of Pi-hole is its ability to filter DNS queries locally, meaning that sensitive data, such as browsing habits, remains within the network. This eliminates the need to rely on third-party DNS providers, providing greater control over the network activity. By blocking potentially harmful content at the DNS level, Pi-hole not only improves the user experience, but also adds an extra layer of security, making it a valuable tool for both performance and privacy. As you can see on the image on the top right of the screen, it is me installing the Pi-hole, and on the bottom hand of the screen is the Pi-hole admin page after it's been completed and queries were added to the browser and blocked from advertising. To complete the VPN setup, I first enabled port forwarding on my home router to open port 1194, which is necessary for the VPN connection. This step ensured that traffic could flow properly between my devices and the VPN server. The installation process itself was relatively straightforward, involving the download and installation of the VPN server and client software. Once the software was in place, the next step was to create a new user account, which would be used to manage and access the VPN functionalities. This allowed me to configure the server setup, set up secure connections, and ensure that the VPN was functioning correctly. With the server and client software installed and the user created, the VPN was ready to provide secure, encrypted connections for remote access. As you can see in between the text is an image of me going into my router settings and adding a rule to allow port 1194 to be accessed. On the bottom of the screen is my complete setup of the user of the VPN, and on the right-hand side of the screen, those three images show the pre-install screen, and then the two other images show the VPN being able to locate the Pi-hole and work together. I encountered several challenges while setting up the VPN, primarily with connecting to the public IP. Initially, I tried the setup on a school network, but I ran into issues because I didn't have access to the router, and the network's IP wasn't static, which prevented me from properly configuring port forwarding. To troubleshoot, I made sure that port 1194 was forwarded on my router to allow the VPN to establish a connection. Realizing that I needed to control over the router, I moved the project to my home network, where I had full access to the router settings. This allowed me to successfully complete both the Pi-hole and VPN installations. However, I faced another issue with Pi-hole, as it wasn't receiving any queries. After investigating, I found that the issue was with the router's DNS settings. I fixed it by updating the router's DNS server to point to the Pi-hole, which ensured that all internet traffic passed through it, allowing Pi-hole to function correctly. This solution resolved the connectivity issues and allowed both services to operate as intended. As you can see on the bottom left of the screen is me trying to connect to the VPN, but it was getting blocked for some reason. So then I later decided to switch my main DNS server in the household by going to the router setup page and getting rid of the previous DNS servers and adding the Pi-hole as its current DNS server. This allowed more access through the DNS server and have queries come in to the admin page. One of the key lessons I learned from this project is to avoid switching locations during the installation process, as it can cause malfunctions with IP addresses and disrupt the installation. This project provided valuable hands-on experience with network security, particularly in configuring Pi-hole and VPN services on a Raspberry Pi. It helped me deepen my understanding of DNS filtering, VPN encryption, and network architecture, while also highlighting the benefits of self-hosted solutions for privacy and data control. The ability to manage both ad blocking and VPN services on my own network felt empowering, and I found the process to be both educational and practical. I would definitely love to do this project again, as I believe having a personal ad blocker and VPN setup is much more effective and customizable compared to using browser extensions on Chrome or Microsoft Edge. This project has reinforced my interest in network security and self-hosting, and I'm excited to continue exploring these areas in the future. Thank you for listening, and have a good day.